Okay guys, so Assalamu alaikum. Yesterday we started function notation, and I had you write down all the information there. And basically, as I was describing, I was saying as what a function is if you put in a value into it, you get one value out. Okay, so and the key there is that one value out aspect. I did mention that the notation is a bit unnecessary, but it is the way it is, and you're going to have to adopt it as part of the syllabus. So let's have a look at these examples that will help you get through your work. And also, being in video format, it will benefit you because you can go back and replay the video as many times as you need to. So let's just get started. So find h-3, h1, and h5. So after the lesson that we had yesterday, you should be able to recall that these mean substitute into the x value for the function h. So as you can see, these are all equations h, and we are required to find the value for all three. I think doing it for all of them is a bit much, so let me just cut it down. You guys can do the rest. So I'll probably just do it for those two. Now for a, we have hx equals 2 plus 2. So if I want to do h-3, then I'm literally replacing all the x's with a -3. It doesn't mean I write 2 -3 here in this case. That's not what it means. As we know, 2x means 2 times x. So that means 2 times -3. You can put in brackets as well. Plus 2. And then you are required to work this out. Calculating this, we get -6 plus 2, which is -4. And that's that. Okay. I'm actually going to reduce this to the one question. That should be enough. All right. And then if we look at the next bit, we want h1. So h1 means I replace this one into the x here. We know that 2x means 2 times. So 2 times 1 plus 2. So if you take notice, these all resemble the original equation. 2 times x plus 2. But x is the one that's being replaced. In this one, it was replaced with -3, as indicated by the function notation. With this one, we replace the x with the 1. And then we just calculate it. So this one here, we get 2 plus 2, which is 4. And then finally, we have h5. So we're going to replace the x's with a 5 this time. Okay, we're going to put them right where the x's are. So we have h5 equals 2 times 5 plus 2. Remember, this part would have been the x. And then simplifying this, we get 12. And that's that. So nice and easy. Shouldn't have any issues with that. Let's move on to the next example. So here we have copy and complete the table of values for each function. So it's basically like everything you've done in the past. I'll just make this table a little bit bigger. So all we're doing, we're replacing, we have the equation fx, and normally you would have a y here. Okay, that pretty much defines what I was explaining to you guys the other day. Fx is basically y. Okay, but we use the function notation to identify that the input value and the output value will be a singular. So just one value will come out. But anyway, subbing this into here, and then writing the result underneath like a normal table of values is all that's required here. Okay, so we go -2 into here. That's going to be +4. So 1 take away 4, that's going to give us -3. Putting -1 here, 1 take away 1 is 0. Putting 0 here, 1 take away 0 is 1. 1 take away 1 is 0 again. And then 1 take away 2 squared is -3. So no problems there. Okay, now the next part is a bit more interesting. I don't think I should do all of them. But I will select possibly, I'll do B, E, and G. So let's start with B. B asked me to find L1 take away 2. Well, I can't do that unless I calculate L1 first. L1 is derived from here. So we're going to replace all the x's with 1. So that means 3 times 1 plus 1, which equals 4. Now, if I want to calculate L1 take away 2, then this is 4, because I just calculated that. So you notice with function notation, if I get a question like this presented, I need to calculate the function part on its own separately, and then I put into my calculation. So 4 take away 2 equals 2. All right, and that's that. Let's try the next one, which is E. We have L1 plus L2. So L1 plus L2. So good thing here, I already have L1 calculated, so I'm going to use that. So L1 here is, L1 here is 4. L2 is the one I need to calculate. So L2, we're going into the original. We're going to put 3 times 2 plus 1, which equals 7. So from the previous question, L1 is 4, and from this question, L2 is 7. So it's 4 plus 7, which equals 11. So hopefully you're getting the gist of it now. And then finally, L negative 2 times L positive 2. I have L positive 2. I just did it from that question. So all I need to calculate is L negative 2. And I'll be doing that from the same equation. So L negative 2, we chuck negative 2 into the x there. So that's 3 times negative 2 plus 1. That will give us negative 5. So negative 6 plus 1 is negative 5. And then finally, L negative 2 times L2. So we bring it all together now. We've determined that L negative 2 is negative 5 times L2, which we calculated here, is 7. And that would result in the answer negative 35. Okay. Moving on to the next one. If you need to obviously revise, or you need a bit more clarification, just slow the video down, pause it, try it yourself, and then move on. So let's look at this one now. Given that fx equals x squared minus 3x plus 5, find the value of this result. So this is essentially the same as the previous question. The only difference is I should calculate all of these f's individually. All right, and how do I do that? Just like what we did in the previous question. I will sub negative 1 into this, get the answer. I will sub in 0 into this, get the answer. I will put 1 into this, get the answer, and then I will use that to calculate this. So let's start off one by one. So f of negative 1 is negative 1 squared minus 3 times negative 1 plus 5. Getting this, we have 1 plus 3, 4, 1 plus 3 is 4 plus 5 is 9. So that's f of negative 1. Let's get f of 0 now. And let me just move this down. F of 0, we're going to replace all the x's with 0 now. So that's 0 squared minus 3 times 0 plus 5. And that equals to 5. And then finally, we're going to get f of 1. So f of 1 equals f of 1 equals 1 squared minus 3 times 1 plus 5. 1 minus 3 is negative 2, plus 5 is positive 3. So that there's 3. So now that I've got those answers, I need to answer the actual question. All right, so we start off with a quarter. That's just there. A quarter. Now begins the substitution. So f of negative 1 is equal to 9. So to make that clear, f of negative 1 equals to 9. So we're going to replace that with a 9. Now notice here we have plus 2 times f of 0. There's a times there. It's just like algebra. 2 times. Now f of 0. If we look, f of 0 is 5. Okay. So we're going to substitute f of 0 with 5. And that means 2 times 5. And then finally we have f of 1, which is 3, as you can see. So I'm going to replace f of 1 with 3. Simplifying this, we get 1 over 4. 9 plus 10, which is 19, plus 3 is 22. And then simplifying this, we get 11 over 2. And that's how you do that question. Okay. All right, let's move on to the next one because it's a bit of a wordy question. I may need a bit more space. All right. I'll leave that there. Okay, write the equation 3x plus 4y plus 5 equals 0 as a function with independent variable x. Okay, so just to make things clearer, the independent variable is not the subject. So if that kind of makes sense. If I have an equation and I've made y the subject, let me be a bit more specific. X squared plus 3x minus 8. Let's say I've got an equation like this. This here is the subject. The subject is referred to as the dependent variable. So the subject is referred to as the dependent variable. What the equation is in terms of. So if you look up here, this is in terms of x as specified by the function notation. That means the x is the independent variable. So if your equation is made up of x's, that's your independent variable. So this part here. So basically, that's why I said earlier, the independent variable is the letter that is not the subject. So here, y is the subject, therefore that's not the independent, that's the dependent variable. So in this case, all it's telling me is to make y the subject, believe it or not. If it's telling me to make independent variable x, it's telling me to make y the subject. So let's go ahead and do that. So we have 3x plus 4y equals 5. Oh, sorry, plus 5 equals 0. We're going to make y the subject. So we have 4y equals minus 3x minus 5. I've just moved them both to the other side. And I'm going to individually divide every term. Negative 3 over 4x minus 5 on 4. And that's it. That's literally it. So it's all about terminology here. Write the equation 3x plus 4y plus 5 equals 0. So it's the same equation as a function with independent variable y. So now if y is the independent variable, I have to make x the subject. So again, we have 3x plus 4y plus 5 equals to 0. I will make 3x the subject. And then finally, I will divide each term by 3. I'm showing you this because this is another way to do it. I know most of you are tempted to just put it over 3. That's fine as well. I'm also showing you that this is the way that I prefer. It depends on the question, actually. All right. And last but not least, this is more of a domain type question. We'll be getting to domain soon. But in each case, explain why the function value cannot be found. Okay, so let's chuck in x as 3. Because that's what it's telling me to do, right? See, I'm replacing the x with 3. Whoops. Square root 1 minus 3 squared. Now, if you calculate this, you're going to end up with square root 1 minus 9, which equals to the square root of negative 8. So in each case, explain why the function value cannot be found. Obviously, there's a number of other questions. I've just chosen this one. But as you can see, I have a negative inside of a square root, which is a mathematical error. So that's all you need to do. You just need to conclude what the error is. So a negative number cannot be square rooted. And this is an important section of this topic where we have to learn to identify values that are not allowed to be substituted into a particular function. And this is part of the key of learning. Now, what I've done, I've left the challenge questions untouched. I haven't taken any examples from them because I'd rather you guys try and give it a shot yourselves. And if you have any questions, you should bring it to class. Okay, but apart from that, go back over this video if you need to for any concepts. If you have any issues, I'm pretty sure watching a few of those sections a couple of times will assist you. And I think that's one of the advantages of having this in video format. But apart from that, enjoy your lesson. I will see you soon, inshallah. Assalamu alaikum.